Hello everyone, this is Douglas E. Welch for Technology IQ. Now, you may have seen in my other regular podcast and blog, A Gardener's Notebook, that I'm getting a little geeky here in the garden. We're out here in my little mini greenhouse, and you're looking at something that I recently put together to kind of reinvigorate my interest in technology. I've connected up with our local hackerspace group, Hackerspace LA. We're actually having meetings already, and we're trying to fund a physical space that we can use. You can find the link down there in the show notes. But Hackerspace LA got talking about Arduinos and Raspberry Pis, and it really got me interested in technology again. I sort of getting burnt out on Windows and Mac and doing the tech support that I used to do. And so I decided to get some devices of my own and play around them and see what I could do. Well, combining my love of technology and gardening, this is the result. Over here you have an Arduino Yun, Y-U-N. This is a kind of a higher level Arduino microcontroller. One of the interesting things that it has two computers in one. There's the Arduino microcontroller on one side, and on the other side there's actually a Linux computer running there, which can connect via wired Ethernet or wireless to my local Wi-Fi and allow me to get more involved with the Internet of Things, which is connecting these devices to various reporting methods so that their information can be queried and shared over the Internet. This is a little temperature humidity, which is this sensor here, and a light level sensor, just using a standard photo-resistor here, which I've tied into the Arduino. I'm reading the status of these two sensors every 5 minutes right now, just to kind of see how it's working. And then they go into the Yun. It processes the data that I get from these sensors. And the great thing it does is, first of all, it logs it to an SD card right here, which is built into the Yun, another great feature of it. Then, over the Wi-Fi, it reaches out, connects to a service called IFTTT, or If This Then That, which you probably know about, and actually saves this data into a Google Spreadsheet every 5 minutes. And the great thing is you can monitor this data in a number of ways. This greenhouse is probably 40 feet from my office, and so I'm not, a display on there wouldn't do me a lot of good unless I was out here in the greenhouse. With this though, first of all, I can monitor that Google Spreadsheet, and it will actually show me as each data entry is pulled and entered in, it shows up in real time on that spreadsheet. Or if you really want to get geeky, because this is a Linux computer, I can SSH into this computer, do a tail command on the data file I'm writing to that SD card, and see it in real time that way from my phone, from my computer, from my Chromebook, whatever. I won't take a lot of time explaining the setup here. It's pretty straightforward. Each sensor only needs power and ground, and then one data line each. The temperature and humidity sensor ties into one of the digital pins on the Arduino, and the photoresistor ties into one of the analog pins on the Arduino. Most of the real work is done by the software, so we'll take a look at that next. And so here is the nuts and bolts of this arrangement, this temperature, humidity, and light level logger. We're just going to work our way through this Arduino code real quickly here. Now I do want to say too, I'm learning this. Yes, I've coded in the past and I'm really technologically savvy, but I don't do a lot of programming, and I certainly haven't done any microcontroller programming before. So I'm sure you're going to see stuff in here that is ugly, and there's already stuff I see I want to change. A lot of it's taken from demos and examples and other things. So please be aware this is a learning exercise, and hopefully you'll learn a little bit as we go along too. At the very top here we have some comments, then we have the includes for the various devices. Simple DHT is the library for the temperature and humidity sensor that we have in there, the DHT11. File I/O allows me to write to the SD card and read from the SD card. And HTTP client is a library that allows me to make a call out to if this then that and register the data and put it in the Google Spreadsheet. The DHT11 is plugged into digital pin 2, and we simply start up the library using this line here. The sensor pin for the photoresistor is in analog pin 0, and we just set up a variable to set it to 0 so we know we have a null value coming in. For the setup part of our program, we simply turn on the serial monitor. I use that for debugging when it's sitting here on my desk. Bridge Begin is the bridge program which allows me to talk between the Linux side of the Arduino Yun and the Arduino side. File system again ties into setting up the file system so it can read and write to that SD card. In the loop of our program, the thing that continues over and over and over as the Arduino sits there, first thing you're going to do is going to get the date and time from the Yun Linux side. Now, one of the nice features of the Arduino Yun, amongst everything else it provides, is because it has a Linux computer on one side, it has a real-time clock, which most other Arduinos do not have. This little code here allows me to basically query the Linux side for the date and time, get it back in some formatting that I can then use later on in the program. This is one of the few functions in the program. In fact, if we scroll down here to the bottom, you'll see the function for getting the timestamp from the Linux side, and you see it reaches out. It basically runs the time command, the time and date command over on the Linux side, gathers that information back, reads it back into the Arduino side, and then returns that value here at the top of our loop. There. Next step, we're going to read the raw temperature and humidity data from the DHT11. We just set some basic variables. Now, the DHT11 sends back its data in binary format, of all things, like 16 bits of binary data. Now, luckily, their demo code gave me exactly what I need to take that. It basically reads that, and it takes the temperature and humidity and converts it into a digital number that I can then use later on, an integer in this case. We're going to read the light level data from the photo-resistor. Now, the photo-resistor is literally just detecting the resistance on that resistor as it changes with light level. Now, reading it is very easy. Light level equals analog read. Basically, reach out to the analog pin, tell me what the value is. Now, the trouble was it returns the value in kind of a backwards mode for humans. The darker it is, the higher the number, the lighter it is, the lower the number. So one of the things I wanted to do is I wanted to change that value so it meant a little bit more to me when I was logging it. So the light level coming from the photoresistor can be between 0 and 1023. What I told it to do with this map command, and I looked this up by searching on inverting values, you found the map command which says, take this level coming from this sensor, which can be from 0 to 1023, and map it onto a range of 0 to 100, and by reversing these two numbers, instead of 0 to 100, 100 to 0, it actually inverts that data for me, so I get 0 being total darkness, 100 being brightest light, and that makes it much more easily readable for us humans. Print temperature humidity is basically some debug code that I've left in there that probably needs to be removed. The next step is we build the file logger string. Now, one of the great things about this, again, because of the SD card, I can log data directly. So I could hook this Arduino to a battery, set it out somewhere, and let it log data to its heart content until the battery failed. I've actually tied it into my USB power bank, which I use to recharge my phone and other devices when I'm on the road, and it runs the Arduino Yun probably for a good 2 days, 48 hours to maybe even 72 hours. So anyway, we build the string that we're going to later output to the text file on the Arduino, and we just build it up using standard strings. We have our date, we have our temperature, humidity, and light level. Simply write them out with commas in between them so it's easily importable into a Google Spreadsheet or anything else we might want to use in the future. Now we're going to build the web update string, which is going to be sent to the IFTTT trigger, which then allows this to get put directly in the Google Spreadsheet. It's very straightforward. Once you set up the maker channel on IFTTT, you'll get some keys, you'll get some code, and it'll show you exactly how to format your HTTP request so that it takes your data and sends it over there. The maker channel on IFTTT has the ability to carry 3 values during each call, and that's what you see here. Just happens to be exactly what I need for this project. Now, of course, if you needed to send more data, you could stuff multiple pieces of data into one of these value strings if you had to, and then expand it later wherever it ends up, say in the Google Spreadsheet. But here it just happened to be I needed 3 values, temperature, humidity, and light level, so that I can send those over to the spreadsheet. The serial print log data is just another piece of debugging code, as is the next line down, which is commented out. Next up, write the data to the SD card. Again, just looking up the example given on the Arduino website and various other places that shows me how to open a file. I'm opening it for append, so that basically the first time it gets called, it creates a file, and every time after that, it simply appends a new line to the data file. And here you can see we're taking the log data we created earlier up here and simply writing that out to the data file and closing it off. I also have a little bit of debugging code here just in case it can't open the file, and actually the file should be weather.txt, which is what I called it here. That was from the default code. I have this set to run every 5 minutes right now. Obviously, you can set this for whatever interval you wish it to run, every 15 minutes, every hour, whatever would be most useful to you, or even each second. In this case, 5 minutes, you have to specify it in milliseconds because that's how the Arduino counts its numbers. So 300,000 milliseconds gives me average of 5 minutes. Now we're going to actually send our call out to IFTTT once we've got all our data each 5 minutes. This HTTP client sets up the ability to reach out to the web. We make a web request using the variable web update, and that's what we set here. Remember, we said the web update is going to be this string here, and so it makes a call out. By doing that, it triggers IFTTT. It says, oh, I got a trigger on the maker channel. What would you like me to do with it? And we'll show you in a minute exactly the variety of things you can do with it. I have this little bit of code here. If I'm watching it here on my desk when I'm debugging, it basically captures the response from the IFTTT channel and makes sure that it succeeded, and if so, what it got. And then we close everything out by flushing the serial line data to make sure there's no data left lying around. And that is pretty much it. Again, the function we use to get the date and time is at the very bottom here. That is about it. I was so amazed that I was so easily able to get this particular learning piece up and running so quickly. I started with reading the sensors, then I started with adding the data to the SD card, then I started to add the web outreach to the IFTTT and the Google Docs and all that, and just built on it piece by piece. So with this running on the Arduino, let's see what the results are on the other side. First, let's look at the data that's being stored on the SD card in real time. And again, because the Arduino Yun is attached to my Wi-Fi and is a Linux computer system, I can do some interesting things, such as this. I can actually SSH, I can make a secure terminal connection to the device over the Wi-Fi. It asks me to log in. I can then navigate over to the SD card that's in the device. And into the weather directory where my data is being stored. Show you the files there. We'll see there's one file, weather.txt. And if you're familiar with Linux at all, you know there's a command called tail, which will monitor a text file constantly whenever it's being updated. So we're going to do a tail-f, which looks at the file, shows us the last 10 lines or so, and then sits and waits for the next line to be added to the file. And when it is, it'll actually show it to us in real time. So I can sit here in my terminal window and simply watch for updates to make sure everything is updating okay. I can also just simply look at the text file by typing more. And there's the entire text file, and we can simply page through it using the space bar, and you see the various values. Now this has been logging various versions of this program, so you may see some different data in here before I've got the light level switched over to a 0 to 100 scale and stuff like that. But at the end of the file, you see our most current entry, 12:55 today, which was just about 4 minutes ago. This SD card, of course, can be ejected from the Arduino, brought into your local computer, plugged in, files can be copied off, files can be copied on, whatever you wish to do with it. Now let's take a look at what happens when that HTTP client command gets issued by that Arduino program we saw earlier. What happens is, if we go to IFTTT.com, if this then that is what it stands for. Now if I click at my recipes up here at the top of the screen, it's going to take me to all of my IFTTT recipes. Of course, the top 3 ones that I've most recently installed are those dealing with the Arduino. And we can see a variety of them. This one says, if a maker event weather is triggered, then post to Twitter. This one says, if a maker event is triggered called weather, then send it to Boxcar, and that's a notification system for my iPhone. And finally, if a maker event weather is seen, then add row to spreadsheet in my email addresses to Google Drive. Let's take a look at that one first. If we open up this recipe, we can see that it says the description that I had there, and it says it's waiting for an event on the maker channel called weather. That's just a name I gave it to say this is this particular event. You can actually have multiple events for your maker channel. When I see that trigger, I'm going to do this. I'm going to add row to a spreadsheet. The spreadsheet is called weather log. It's going to be formatted in this method. You can actually fiddle around quite a bit with this formatting. This is pretty much the default format. I'll let you know that the 3 vertical lines indicate a column break. So it actually will spread this data out into columns automatically for you, and then where it's storing it in the Google Drive folder path. So if we go over now to that spreadsheet on Google Docs, you'll see here's the actual data, and it's currently bringing in data. In fact, it just triggered at 1 o'clock about 2 minutes ago, and this is the data it brought in. The date and time, the trigger name, temperature, humidity, and light level. And you can see how it varies over time. If we sat here long enough, we'd actually see it automatically add the next line to this in about 3 minutes, so we're probably going to miss it. But you'll see the lines appear here in real time as soon as they're triggered by the IFTTT recipe. Now let's go back to IFTTT for a moment. Let's go back to channels, because one of the things we had to do is we had to set up this maker channel. Now this is totally free, by the way, which is actually very nice. It allows you to do some very interesting things without spending a lot of money. The Arduino Yun comes with some drivers for a service called Tembu, but Tembu, while has some free services, it begins to charge you after so many requests and things like that. So I've stuck with this for now. So when the maker channel is set up, you basically have 2 things. You can trigger and have an action. So you can say, when I get a web request with my key and appropriate information, do something. Or I can also tell the maker channel to request data from somewhere else. Now in my case, I'm just using it to respond to this web request. Here on the maker channel page, there is a great information on how to trigger events, which you can learn how to use this channel. It took me a little bit of fiddling. I had to learn what it wanted to be replaced. It wanted the event name here in the URL. And if I wanted to send values, I had to send a JSON body, or you can use, as you saw perhaps in my URL that I used in my Arduino program, I was just using the standard post and get notation for variables in the URL. And then of course, using the button at the bottom, you can do a quick test of it. You can actually copy the URL it creates too, paste it into a new web page, and see if that triggers the event. Now, as you might imagine, you're not limited to using these maker channel triggers for just Boxcar or Google Docs. You can use it with any of the compatible services here that make sense. Obviously, you wouldn't use it with Spotify, but you might write a note to your iOS notepad. You could log it in a variety of fashions. You could post it to your WordPress blog, for example, up here, or your Medium, or your Tumblr, or whatever. You could send it to a Slack board if you wish to share the data with other people on your Slack boards. Really, it's only limited by your imagination what you can do with this data once you've used the Arduino to capture it and then send it off to IFTTT. Here's what it looks like when the Boxcar app on my iPhone receives the information when it's sent from the Arduino to IFTTT. You can format this message in pretty much any way you wish to. I just simply made it very quick and succinct for easy readability. And finally, this is what it looks like when I have the IFTTT trigger set up for my Twitter account. It simply formats the data that I got from the Arduino and sends an automatic Twitter to whatever account I choose. Thanks for watching this episode. I hope you found it useful and entertaining. I know that I certainly learned a tremendous amount about the Arduino and all the associated services as I worked through this project. It's been a great learning experience, and it's only spurred me on to look for even more projects where I can apply the Arduino and learn even more about it and other systems like the Raspberry Pi. For more information on my technology travels, check out the website techiq.welchwright.com. There you'll find links to information about Arduino, Raspberry Pi, and a host of other technology topics. Again, techiq.welchwright.com. Until next time, control your technology. Don't let it control you.